So hey everyone, this is your practice midterm one review session. I'm going to be teaching, or rather reviewing with you everything that you require to solve problems in your practice midterm one. Um, Let me start with those questions that require the use of R. And after I'm done with the R markdown, we'll be taking questions that are not related to R, interpretation, theoretical, whatever. We'll come to you and give you help with that. All right, okay, I'll get started with this. I believe the first question that requires the use of R is the 12th question. But, um, yeah, okay, all right. Let me just go to the 12th question in case. All right, so this is what it reads. The question uses the data set restaurants.csv. It's just a hyperlink. You can click on it and download the data set. Contains data on 1,000 restaurants with the following information. Location, seating capacity, dinner service profit, and owner age. So you're predicting what the profit of the restaurant would be using all the other variables as predictor variables. But now for this specific question, he says using the regression from the previous question, which is to predict profit from seating capacity, advise a new restaurateur who's thinking about opening a new restaurant how much profit to expect. He would like you to give him a range of profits to expect for his new restaurant, which has 200 seats. So what kind of an interval are we talking about in this question? It's a prediction interval. Why? Okay, you'd essentially like to predict the profit on a new single restaurant that this guy is planning on opening. So it's a prediction interval and not a confidence interval. Well, we've already seen that you need to build a model first to be able to do this. And first, I'm importing the CSV. Remember that the CSV file should have been downloaded and kept in the folder here, which you're going to be using as your working directory. And after that's done, I'm using the read.csv command to import the data into my global environment. Now I'm building a model. I'm calling it model one. I'm running it as a linear model statement, LM, of profit against seating capacity and referencing data equals raw data. Any questions so far? Yep. Yeah, that's what the question wants you to predict for this particular question. He wants you to predict profit for just seating capacity. All right. Yes, you should. So we also observed that there are two forms of writing the LM statement. One is to directly reference the data in front of the variable name, dollar and the variable name, but that gave errors when you were trying to run the predict.lm statement. Instead of giving a single value, it's turning on multiple values. So this form would avoid that issue. If you just write the name of the variable and then comma reference the data. Questions? Yes. That is correct, yes. So how the predict.lm statement works is you need to be given values for each of the x variables that you want when you're predicting the y, right? So you should essentially be given a list of x variables if you have more than one x variable. Yes? Uh-huh. All right. So if it's not mentioned in the question, you should take it as 95. That's the default, all right? Question. Yes. Yes, that is correct. Yes. Okay, so the restaurant, the guy who's opening the restaurant, he's trying to open one new restaurant, and he wants to know what the expected range of profits is for a restaurant that has a seating capacity of 200. All right, so it's one restaurant, and confidence intervals are those intervals that are built upon mean of different a set of values, whereas prediction interval is for one particular Yes. Um, the question probably would have been worded not like a guy is trying to open a restaurant, not really. It would be something around the lines of, say, what would be the profit, mean expected profit if I have a restaurant with seating capacity of 200? Great. Question? Yeah. So in this question, probably it's just the lack of like miscommunication or whatever it is. But in the question, it's not specified. In this particular question, it's not specified. And if it's not specified, the level is always 95. Right? Yes. Yes. And you don't need to type that out here. Ours automatically takes it as 95%. If it's anything other than 95%, then you have to specify level equals whatever that number is. Okay, I'll move on. Now I'm using the predict.lm statement. The interval would be prediction and not confidence. Um, and what I'm doing here is, this is how the predict.lm statement works. First, you have to reference the model that you built and comma, the list of x variables for which you want to predict y. In our case, there's only one x variable, seating capacity that equals 200. So I'm just writing a list that has my x values. So the purpose of writing a list is that you can add more x values inside it using commas. Yes. This doesn't really require the list, but I'm just using it to demonstrate that if you have more than one x variable, you need to use the list function. And yes, okay. And interval equals prediction. So this should throw you three values. One is the fit value, which gives me the absolute value of what that profit would be, and it gives me a 95% prediction interval for that profit. Questions? Yes. Hmm. If it does not specify, always round to four places of decimals. Because if you observe in Canvas, when you try to enter two places of decimals, it takes in two more zeros after it. So sort of like set to default of four places of decimals. So yes. Okay. On R. Okay. Yeah, I think there's a setting that you can go and access. I'll actually get back to you on that. I don't remember exactly where that is, but there is a setting where you can go and change that to the number of decimal places that you want. Or I think you can use the round function. Um, yeah, that would be an alternative. Something like that, yeah. Yes? Yeah, okay. Okay, all right. So that would be the 12th question. So um, he's asking for a range of profits to expect for a new restaurant. So the lower value and the upper value would be the range. And yeah, that'll be it. Okay, I'll go to the next question. Yes. I mean, that's sort of like the key words, but you're supposed to explain. I mean, you're giving him an advice, right? So just, all right, okay. The next question is to run a regression predicting profit from seating capacity, whether or not the restaurant serves dinner, the location, and the age of the owner, all right? And he's asking you what variable we should consider eliminating from the model first. For that, now I construct a linear model. Um, and once I construct the linear model, I should be eliminating that variable that has the highest p-value from the regression statement. Would you agree? Right, but when you can look at p-values, just look at p-values so that you don't get confused. Because at times the p-value is a negative number. Yeah, so you need to like look at the absolute and stuff like that. So it's always like easier to look at the p-value and eliminate the variable that has the highest p-value. Yes. Not really. No. The x variables, the order of the x variables that you enter in the LM statement, that doesn't matter. Okay, so I'm building another model that predicts profit from the other four uh, predictor variables, referencing the data again. What have I done? Yeah, it's run. Okay, and I'm printing the summary of that model. You can see from the screen that location upstairs and owner age, these two variables, they're not significant at the 95% level. You can see that the p-values there, they say 0.155 and 0.433, and they do not have any stars next to them, which means that they're not significant. They're not significant. All right. So in this case, which one would you eliminate first? The one with the highest p-value, right? So I'll be eliminating the owner age, which is what the question asks for. Eventually, what you have to do is you have to run another iteration of an LM statement again, eliminating that owner age variable, and you have to run that again and see if some other variable has become insignificant. So that's how you do the backward elimination process. Yes. Uh-huh. No, you can't. You can't. Yes. I'll get to that. All right. All right. Go to the next question. Um, this one says run a regression predicting profit from seating capacity, whether or not the restaurant serves dinner, location, and the age of the owner, and asks you for which assumptions are satisfied. So remember that any linear regression has four assumptions: L, I, N, E, linearity, independence, normality, equal variance. It's the easiest way to remember it. So just using that abbreviation once more. And the question asks, so he's given just three options, and it's sort of like an MCQ where more than one answer could be right. So just make sure you see if it's a round box or sort of like a square thing. So you know more than one value to enter. Okay, so now we talked about plots to check for all these assumptions. I'm going to be using two kinds of plots here. I don't have to check for independence, obviously. Anyway, no plot can check for independence, but I can plot residual plot, and I can plot the raw data of y against my axis. That would be scatter plots, and then I can plot the histogram of the residuals or the QQ plot of the residuals. All right. So I'm first running the residual plot. So I'm finding the residuals for my model. So model two would be the regression model that I ran for all the variables, and I'm first finding the residuals of that model. The command to use would be resid of model two. I'm naming it as res2, and I'm going to be plotting that residual plot. All right. So what do you see from here? What is expected to be seen from a residual plot for in terms of equal variance? Anyone? It's supposed to be random, and you're not supposed to observe any sort of like cone shape pattern going on. You can see that it is a sample that I think the sample size is around 1,000, so there are bound to be some outliers, but you can see that it's fairly random. So I can say that the homoscedasticity condition is satisfied. All right. And now I'm going to be checking for linearity. And the best way to do that would be to use scatter plots of y against each of my x variables in the model. By doing that, first I'm plotting owner age against profit. You can see that this is a categorical variable. Okay. It is a numeric variable, but sort of like, yeah, yes. No, it's fine if you can use the scatter plot on raw data. Really? Hmm. Okay, I'll actually confirm that with you. I'm not really sure at this point. So they're saying that for multiple linear regression, you can't really plot the raw data, the y's against x's for linearity assumption. They're saying you're supposed to plot the fitted values. Is what Monisky said in class. Okay, but is it wrong to plot the raw data and check for linearity? Okay, all right. If it's a multiple regression, you're supposed to plot the fitted values. Let me see if I can pull that up from the lecture. Okay. Yeah. Hmm. Hmm. Okay. Hmm. Yeah, let me just try to plot the other one. Okay. All right, and I'll plot the AB line as well. Yes. Equal spread is just for the homoscedasticity assumption. You do not observe any sort of like pattern going on. So when I talked about homoscedasticity, I talked about it being random, and you're not really having cone shapes pattern, right? But if you observe sort of like an S-shaped curve or something going on, then you know it's not linear. You're not supposed to observe any sort of pattern in the data. It's supposed to be random and it's supposed to be equally spread. And then you can say that it's linear and homoscedastic. Right? Yes. Yeah. That's not going to give you the same thing. So this is going to be giving me the plot of residuals against the index. So this index would be my data. So that's my sample number. Like I have 1,000 rows of data, right? So that gives me data arranged by rows. Yeah, you can. Yeah, I think I've had some misconceptions. Probably you'd be better off plotting for multiple linear regression residuals against the fitted values. And then you can observe both linearity and homoscedasticity from that plot, yes.
Yeah, but that's not always going to work. Because, like you just said, this is plotting against an index. There are 1,000 rows. This is plotting against rows, which is kind of like when we did football residuals. I told you how that's a bunch of BS because it's just a random plot. Is what it's
Mm-hmm.
Now you can see that this one. I mean, this one it just so happens to be okay because it's so scattered. It doesn't matter if you slice it up however you did. But that's why plotting it versus the
Fitted values.
fitted is a much better way to look at it. Even though it puts dots in your mind because we saw how it was, it's very slight on one side of it. This just happens to, this happens to be okay in this situation, but it's not the best way to look at it. It
Yeah,
may fool you sometimes.
yeah, probably in another case you could observe a lot of clustering over here, and then
Yeah,
it could be scattered in the other indices.
This is fine in this example, but
Yeah. So to answer, yeah, residuals against the fitted values for multiple. Yeah, sure.
why we only check
Sorry.
age for linearity.
Yeah. Oh no, there are the other two variables as well. It's just in comments below that. I didn't want to run all the.
He put them here. He checked them all. He just put them in
I just put them in comments. Yeah. 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 Generally, just use the quantitative variables for linear. Yes, that's not. You can't really like plot a raw data against the categorical variable and talk about linearity in that case. No, you can't. Yes. Okay, and finally, you can see that from this, I'll run this again very quickly. You can see that there is no funny pattern going on here. It's again random. There are outliers, but for the most part of it, it looks decent. So I can say that the linearity assumption holds good as well. I'll check that. And the last one is the normality condition, for which I plot the histogram of the residuals. or I can plot the QQ plot of the residuals. So always remember that if you're using an RMD file, run this QQ norm and QQ line, both these commands together, because if you run them one by one, it's not gonna show you the plot. So running them together would give you the line as well as the points for the QQ plot, right? Yes. Oh, I meant the plot and the AB line together. Oh, what do you mean? No, you don't have to. So that's plotting the raw data, but it doesn't really make sense for a multiple linear regression. Yes, yes. Sorry, it should be the same thing. Yeah, the QQ norm would just give you the points, and then you put the QQ line, which gives you the. That's why you do it together. Okay, you can see that here as well. The reference line and the points nicely align with each other. So I can say that this data is from a normal distribution. So normality of errors also holds good. Questions? Yep. Hmm. So honestly speaking, it's very difficult for you to visually analyze something and say if it's absolutely equal spread or not. So if such an ambiguous question arises, it would be worded in such a way that they're asking you to give an approximate answer. So it'll be like, is it roughly homoscedastic? Is it roughly normal? This is what the question would be in that case. All right, I move to the next question. Okay, so now he's asking you to run a regression predicting profit from seeding capacity, whether or not serves dinner, and the interaction between those two variables. The coefficient, here it refers to the coefficient of the interaction term, indicates what? So I'll just run the model now. It's profit against dinner service plus seating capacity. So there are two ways of writing this. One way would be to define seating capacity times dinner service before the LM statement, name it as a new variable, and referencing that variable name inside of the LM statement. That would do the interaction. This is the second way to do it. Whatever single variable that you want, and then for the interaction term, you can use a column. It causes errors for some reason if you do that. Yeah, or just define the interaction term right before the LM statement and then reference the object inside. All right. Okay, I'll run that one now. I'll take your question in a minute. I'm printing the summary of the model. Okay, you can see that this interaction term here, in our case, it's not statistically significant, but he's asking for the interpretation of the estimate value for the interaction term. How do you? No. So when you reference it, you could either add it as a new column to the existing data set, or you could just have as a separate set of values. All right. Okay, so how do you interpret this minus 5.163? Anyone? Okay, so the first option says the predicted effect of adding dinner service is $5.16 less in profit among restaurants with the same seating capacity. Is that right? Why? it need not be same seating capacity. Whereas what the interaction term, for example, here indicates is that, so you can see that, so this regression equation can be written as what? Profit equals 31632 plus 20960 times yes, right? Plus seating capacity times 108 minus 5.163 times yes times seating capacity. All right. So here, by doing this, what R has done is to keep no dinner service as the base variable. All right. So the base variable in this case is no dinner service. By printing out this, it tells me that this slope assumes a value of 2960 when there is dinner service present at the restaurant, in which case that variable goes to 1, is all it does. All right. Seating capacity is a numeric variable. You don't need to worry about it. And then the dinner service times seating capacity, that variable, how do you interpret that variable? So this tells me that for all restaurants that have dinner service, the expected profit goes down by $5.163 per seat. Agree? Because you're multiplying that by the number of seats that are there in your restaurant, given that there is dinner service. All right. So the yes is always assigned to 1. Because if this goes to 0, then what happens is this goes to 0 and this term goes to 0 as well. So you're left with nothing but the intercept and the slope of the seating capacity. All right. So yes, it is. The base is always 0. Questions? Questions? So how do you interpret this? You interpret it as for all restaurants that give dinner service, the expected profit goes down by $5.163 per seat in the restaurant. All right. So that should be one of the options in the question. Uh, Predicted profit per seat is about $5.16 less per restaurants that offer dinner service. All right. Questions? Yes. Okay. All right. I'll move to the next question. Okay. Hey. Now he asks you to run a regression predicting profit from location. That's all they want, right? So your restaurant location is either upstairs, street level, or in the basement. Now, what can you conclude? Check all that apply. All right. So now I'll run the regression for profit against location, and I'll print the summary of that model. So this is what it looks like. Again, R has assumed that um, basement is the base variable. That assumes a level 0. All right. And now you have location street and location upstairs. So it's essentially like this. If location is street, then this variable goes to 1, and basement is the 0 variable. Or if location is upstairs, this variable is 1, and the basement is 0. That's how it does it. All right. So what do you observe from here? Can you observe? What's the first thing that you observe? Always look for the p-value. You can see that location upstairs, that variable, is not significant. All right. So you can, however, see that if my restaurant is located upstairs, so always remember that when you have a question like this, if my restaurant is located in the basement, then what is my expected profit? Anyone? Just the intercept, right? So it's $60,392 because the other two variables are 0. All right, so these two go to 0. Now, when I have my location upstairs, this goes to 1. All right. So it's 6,392 minus 1,086, which means that it is more profitable having a restaurant in the basement than upstairs, but it's not statistically significant in this case because the p-value is higher than 0.05. So remember to read the question properly. In this case, the question says that it is statistically significant, or rather, it's statistically significantly more profitable to have a restaurant upstairs than in the basement, which is not true um, because it's not statistically significant, that variable. All right. But you can see that the other variable is statistically significant. So what does this tell me? Location street, right? You can see that it is statistically significant. Now, again, having a restaurant in the basement gives me a profit of $60,392, but having it on the street gives me $9,368 more, which means that it is statistically significantly more profitable to have a restaurant on the street than in the basement. Yes. It did not take it out, it rather assigned it to a base variable. So always remember that when R creates dummy variables for you, or rather any statistical software that creates dummy variables, will have one level less than the total number of variables that are there in the category. I mean, total number of levels that are there in the categorical variable. Right? I don't have an answer to your question. Yes. Sorry? That's actually a really good question.
What? His question?
No.
What is it?
He says that what if I need to compare location of street against upstairs because both of them are printed. I just take.
So wait, go back and ask me
Oh
again.
yeah. You can. You can tell me how. If it's on the street, this goes to 0. You can still calculate the profit. If it's on, if it's upstairs, this goes to 0, and you can still calculate the profit. But just because in this case upstairs is not a significant variable,
But you can also they can both be zeros, which means it's
definitely in the basement,
in the basement.
which means it's just the estimate of the intercept.
Compare. Um, which no, they're all three variables. So that's like if they're both zeros, you find out how much the basement is, right? If this one's a 1, then this is almost 70,000, right? This one's a 0. So, and if this one's a 1 and this is a 0, obviously basement's a 0, then this is almost 59,000. So you can compare them all. You just have to think that it's three variables. They can both be zeros. Now, one of these does not have to be a 1. Okay, it's just like the days of the week. You know, if there's 7 days of the week, how many dummy variables do you make? 6, and you assign them however you want. You know, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Maybe Sunday's the one that gets thrown in there. And it all depends. So, and when he asks about how R assigns them, it's based on strength and their relativeness. So, if there is a very significant part of how R assigns them. It's obviously going to assign yes. If it's a dummy variable, yes, no, it's always going to assign yes, right?
Mm-hmm.
If it's a categorical variable, it's going to try to balance them, okay? And 0 will be in the middle, and there'll be some on the top and the bottom, and it's generally based on significance. Not always, but if you look at this one has a positive value. This one has a negative value. The part that's in between there, that's the basement, is very close to this one. So you can make the assumption that it's not as significant as this, but it's not as poorly significant
What's
is
that?
this. Now, there's a weird time when they all are negative and one of them is positive.
Mm,
And that's based on one of them is statistically significant and the other's
right.
not.
Yeah.
Okay? Or it's just that much more significant. That means that the one that's not, all of these would be negative, and the one that's not showing is positive. It can also happen the other way around, where one of them is so insignificant and others are positive. It's generally not balanced. But it's more often than not, you're going to have a couple on top, a couple below, and whatever in the middle. Somewhere in the middle as far as significance goes. Because this, you see how this is not almost 9 times more significant than this? It's 9 times further away from zero
Hmm.
in a way, and that's on the negative side, that's on the positive side. So there is some relevance and significance when it comes to uh, importance.
So when we're comparing between the string and obtuse, um, and we're making like one of the variables zero, right?
You're not making it ours. Yeah.
But are we changing the base variable right now?
No.
Are we what?
Are we changing the base variable right now?
What base variable?
Like we're making like either a string or obtuse or zero, but like
We can make them both zero. Because there's 3 choices. Remember?
so we can just like switch the base variable like whatever we want.
No.
So R automatically assigns it.
R automatically assigns it. What I'm saying, so if you have a category that's let's say 4 different colors, red, orange, green, blue, okay, and you're doing some sales deal, and you throw that category in there. One of those, let's say red's the most significant and has a positive uh, coefficient, and let's say green, blue have negative. This is probably going to be the one that's thrown in as zero. It's non-existent. So when all these are zero, it defaults to this one. Okay? That's kind of what happens is, in reality, that value is thrown in, we've always said it's thrown into the intercept.
Yes.
Okay, so this is a specific question.
Hmm. Sorry.
I forget. Um, so why did the 108 point, like, I know the regression equation was like 108 point
Hmm.
something minus,
Hmm.
yeah. So where did it go in this? Like how, in number 17, like when calculating the percent change?
Oh, because can you show me that? So there was something like, do you remember what the equation was? I think it was 258 point something. Okay, whatever that is, right? So he's asking for a change in P, right? So um, let me assume that my base P was 1. A 10% change would have been 1.1, right? Increase would have been 1.1. Agree? I mean, I can assume it to be anything. It's just a matter of ratio, right? So this ratio is 10%. Agreed? So what is the change in my MPG? Are they done with it? I'm actually going to be talking about this question now. So yeah.
It's actually, yeah. No. Question.
Okay. So yeah, that is correct. Yes. Okay. All right. So I'll go to question 17. Someone had a question on that. So we're predicting miles per gallon using. So this is the regression line that you get from that 108.7 minus 18.58 times log HP. So this is actually printed from R. So the log actually is a natural logarithm, and it's not log to the base 10. All right. So we're talking about a two. Yes. So for the purpose of this course, you're going to be working everything on R and not your calculators. So every time you see a log on the screen, know that it's ln and not log. Yes, it's always going to be ln. Unless and until it's specifically said that it's log to the base 10, always ln. All right? And remember that R takes an log as ln. So don't try ln and be like, okay, it's not working or something. That's what I'm saying. So yeah. So the log statement has an extra clause inside it where you can enter the base. So base equal to 10. The default setting is the value of e. But if you want to find log to the base 10, you have to enter an extra parameter. Yeah, of course. Log, yes. Yes.
I got the right answer, but just in positive form, and I was wondering why it's negative because if we are.
I'll tell you that. I'm getting to it, please. Thank you. All right. So, yes. Okay, so he wants you to predict the change in miles per gallon for the 2017 model, which he says has a 10% higher horsepower than the 2016 model. So we're doing the 2017 model minus the 2016 model, right? So he's saying that there's a 10% increase in horsepower. So if I assume the base horsepower to be 1, I can assume it to be anything, right? It's just the ratio that matters. If I assume it to be 1, then the 2017 horsepower would be 1.1, right? So the equation that I would write in that case would be 108, whatever that is, minus 18.58 times log of 1.1, right? That's for the 2017 model. And for the 2016 model, it's again 108. Because I need to have the whole thing in brackets, I'm removing it, so it'll be plus 18.58 times log of 1. All right. Someone asked me why the 108 does not appear. It's because it gets cancelled. You're predicting the change. When you're predicting the change in y, always remember that the intercept term goes off. Yes? Yes? No, I told you, like, R doesn't take in ln. Log is ln in R. So, all right, okay. Uh, Yeah, so by doing this, I'm just eliminating 108. So I'll just write it as this. It's 18.58 times log of 1 minus log of 1.1, which is minus 1.77. Questions? Yeah. What did you do in your calculator? 0.77 is what you got? It's because you entered log and not ln. I did the same mistake when I solved the problem, so I know. You would have calculated the log to the base 10 on your calculator instead of ln. All right? It's minus 0.77 when you calculate the log to the base 10 instead of the ln. All right? Okay, all right. So that's the 17th question. Sure. Um, there could be simple regression as well, but since you've proceeded from simple to multiple, expect more questions on multiple. No, don't worry about it. Okay. All right. So that would actually be the questions that require R. Everything else is either interpretation or theoretical. So if you have any specific question that you'd like me to discuss, I'll be happy to do that. Yes? Okay, all right. So again, MPG, and you're given the regression equation for that. It says 30 minus 1.5 times number of cylinders plus 2 times auto transmission, yes. In this case, the base variable would be no. Plus zero point 0.1 times number of cylinders times auto transmission, yes. Right? So he's asking you which of the following is not correct. So make sure that you read that word not properly. I made that mistake when I solved it. Um, yeah, so select all that apply. Number of cylinders in auto transmission interact with each other. Would you agree? Is it the right answer or is it not? They do interact with each other. So you're not supposed to take that, right? Right? Sorry? Like there is an interaction variable, right? So it's saying number of cylinders in auto transmission, do they interact with each other from the regression equation? Actually, it should have been like, is there an interaction variable between number of cylinders in auto transmission? Because if you actually ran the regression and printed out the summary, it could be very well, this could have been a high p-value and it could have been insignificant, in which case they did not interact with each other. So the option should have been, is there a variable, is there an interaction variable between number of cylinders and auto transmission? In this case, there is, so you're not supposed to tick it. Second, when auto transmission is present, MPG prediction is always 2 miles more compared to a similar car with the same number of cylinders but no auto transmission. Is that correct? Why? Interaction variable, right? So I'm just assuming that, what, 2 miles more. So I'm just assuming that this is all auto transmission is about. There is another interaction variable that you need to take into account. So it's not always just 2 times more MPG. You're supposed to put that as an answer because it's asked you which of these are not correct. The answer is correct, but the logic is not correct. And he wants you to give you the answer for something that's not correct, right? Yeah, yeah. So I was just saying that it's not always 2 miles more compared to a similar car because by saying that statement, you're essentially trying to say that this is all the auto transmission term. There is another term that has auto transmission in it. There's another auto transmission term that depends on the number of cylinders as well. So it's not always just 2 miles more. You have to account for this interaction term as well. Yes. You need to look for that one keyword that makes the answer wrong. If that's the case. You know something? If this question was worded at least 2 miles more, would that be a correct? Yeah. Understand the logic? Sorry? Sorry? Minus? Yeah. Okay, all right. Maybe I'm wrong. I shouldn't try to experiment too much. Okay, the third option for any given car, increasing the number of cylinders will reduce the MPG by 1.5 miles. Is that right? Go on, guys. Increasing the number of cylinders will reduce the MPG prediction by 1.5 miles. Why? Correct, yes. And then auto transmission increases fuel efficiency, does it? It does because both the variables that have auto transmission in it, they're positive slopes. So remember that when there is auto transmission, MPG is always high. So the correct answer would be this and this. All right. Any other question you want me to discuss? 7? Oh yeah. Again, you're not accounting for the fact that there is another interaction variable here. Right? Just a second. I'll go to the 7th question. Someone wanted me to discuss that. All right. So what do you mean by independence? What do you want to see in your data? So what do you see in a time series data? The y, the new y, can be explained by the older y, right? That's what a time series data is, right? The new predicted value depends on the older predicted value, right? That's what a time series data is. So that means that That means that for the independence assumption, it's necessary to determine whether the y variables, y values predict each other. That's what's important, right? And because of this, time series data often violates the independence assumption. All right? I can't hear you. Everyone, please. I'm trying to. Yeah. Uh huh. I'm
Oh
sorry.
shit.
Oh,
Okay. How
sorry.
can you say that?
18. Yeah.
Okay. How can you say that this would decrease APG by 1.5
It
if
won't.
there's an inter?
That's what. So it's asking you for answers that are not correct.
Okay, I'm stupid.
Any other question? All right. Just ask me the question. Yeah. It's not always true. Yeah. Anyway, the answer. I mean, do you agree? Yeah. It's not always true, right? Doesn't if the number of cylinders decreases or increases, then again it would be something else. Agreed. Sorry, I don't. Uh-huh. You can't really say if it increases or decreases. That's your question, right? Yes. Any other question? Yes. I'll just answer it like, yeah.
So I'm not sure. I'm not sure why this is true. I know that it is true, but I don't know why.
I'll get back to you. So that would be this.